Good day, viewers. My name is Audrey Polton. Welcome to Lesson 3 for Grade 10 and 11 Mathematics. The topic for today is solving simultaneous equations by elimination. Let's have a look at the objectives of the lesson. By the end of today's lesson, you should be able to solve simultaneous linear equations with two unknowns by elimination. Let's work with the equation x plus y is equal to 10. Let's introduce another equation which has two variables. X minus y is equal to 2. Now let's explore these equations further. You might not know that it is possible to add or subtract equations to obtain a new equation. This is how variables can sometimes be eliminated. If we name the equations, we can show what we are doing. I called them equation A and equation B. Look at what happens if we add these equations together. 1x plus 1x makes 2x. But positive y and negative y add up to 0. They are called additive inverses. This means that there is no y term left. On the right side, 10 plus 2 makes 12. By adding the two equations together, the y has been eliminated. Now that the new equation only has the variable x, we can solve it and find that x is equal to 6. Using 6 for x in equation A, we see that y is equal to 4. Here is another example. Solve 3x plus y is equal to 15 and 5x minus y is equal to 17. Do you see that once again the y terms are additive inverses? One is positive y and the other is negative y. This means that if the equations are added together, the x terms add to 8x. But the y terms will add up to 0 and will therefore be eliminated. On the right side, the numbers add up to 32. Now we can solve the equation 8x is 32 by dividing both sides by 8 to get x is equal to 4. Once you know that x has the value 4, substitute 4 for x in either of the original equations. I chose A. This gives 12 plus y is equal to 15. Subtracting 12 from both sides gives the solution y is equal to 3. The solution for these simultaneous equations is x is equal to 4 and y is equal to 3. As long as the two of the terms in the equations are additive inverses, then when you add the equations together, those terms will be eliminated. Look at this example. 3x plus 2y is equal to 16 and minus 3x plus 5y is equal to 19. In this case, it is the x terms which are additive inverses. When positive 3x and negative 3x are added together, the answer will be 0. The x terms have been eliminated from the equation, leaving only the y term of 7y and the number 35. Now you can solve for y by dividing both sides by 7 to find that y is equal to 5. Knowing the value of y, you can substitute 5 for y in one of the equations to find the value of x. 3x plus 10 is 16. Subtract 10 from both sides to get 3x equal to 6, which means that dividing by 3 gives x equal to 2. The solution for these simultaneous equations is x is 2 and y is 5. From the examples you will see that having additive inverses is the best possible scenario in order to eliminate one of the variables. You just need to add the two equations together. How would you do this next example? Write it down and try to eliminate one of the variables for yourself. Did you realize that the x terms are additive inverses? If you add the equations together, the x term will be eliminated, leaving 6y is equal to 36. Dividing both sides by 6 gives the solution as y equals 6. Now that you know the value for y, substitute 6 for y in one of the equations to solve for x. I would choose to substitute it into b. The working is shown and you should see that x ends up being 2. But what would we do if there are no additive inverses? Here's an example of what I mean. A very common mistake is for learners to just cancel the y terms because they are both the same. There has to be some simplifying or an operation of some kind before the terms are eliminated. In this case, the y terms are not additive inverses because they are both positive. Adding the equations would make things worse, not better, because we would end up with 4x plus 10y. But this time we can subtract the two equations. 3x minus x is 2x, and 5y minus 5y is 0. So the y terms have been eliminated. On the right side, 41 minus 37 leaves 4. Dividing both sides by 2 gives the value of x as 2. Substitute 2 for x in equation b to lead to the value of y as 7. We can make a rule for ourselves at this stage. If you have additive inverses, add the equations. If the terms are exactly the same, subtract the equations. But be very careful when you are subtracting in algebra, especially when there are negative signs involved. Look at this example and decide what the next line would be. The x terms are exactly the same, so we need to subtract to eliminate them. When you subtract, you need to change the signs in the equation being subtracted. We want to subtract the whole of equation b from a. Remember that in algebra, subtracting is the same as adding the inverse. The minus in front of the bracket makes all the signs change, which gives the inverse. Now we have negative 7x and positive 7x, which when we add together makes 0. The x terms have been eliminated, leaving 6y is equal to 18. Divide both sides by 6 to get y is equal to 3. As before, this value is substituted into one of the original equations. I chose A. The process is shown on the screen and you will see that x works out to be 7. In all the examples we have looked at, the values of one of the variables were already the same. But what happens if they are not? Luckily, because you are working with an equation, you can do anything you like to that equation to change it to what you want, as long as you do the same thing to both sides of the equation. Here's an example. 3x plus y is 17 and 2x minus 3y is equal to 4. 3x and 2x are not the same, and plus y and minus 3y are not the same. However, it is easy to change 1y into 3y by multiplying by 3. The y terms have the added advantage that the signs are already opposite. One is positive and one is negative. Let's multiply the whole of equation A by 3. Remember to show what you are doing so that you or anyone else can follow what you did. Now that you have multiplied by 3, you have positive 3y and negative y, which are additive inverses, and we can go ahead and add the two equations C and B together. 9x plus 2x gives 11x. The two additive inverses add to make 0 and the numbers add to 55. There is only an x term left, so you can now solve for x. Once you know the value of x, by substituting, you can find the value of y as 2. The solution is x is equal to 5 and y is equal to 2. Spend a few moments looking at these equations. We've come to the end of the lesson. Let's summarize what we have learned today. I hope that by now you have a better understanding of simultaneous equations and how to solve them by the elimination method. I have tried to show you how useful it is to create additive inverses. If you use them, it means you can always add the equations together, rather than sometimes adding and sometimes subtracting. Subtracting in algebra is where many learners make unnecessary errors. Solve for the remaining variable, substitute to find the value of the other variable. The next step is for you to practice as many examples as possible. The steps that you need to follow are always the same, which means that it is possible to learn how to do them. Regular practice of as many examples as possible is the key to success in math. Viewers, we have come to the end of the lesson. Thank you for watching. Until next time, goodbye.